Okay, without your calculator, convert the following decimals to fractions, showing all working out. The key here is to know which values are repeating and which aren't. So for number 1, or 3a, sorry, you have 0.167, and there's a line over all three values, which means that all three values are repeating. So we can write this as 0.167. Okay, now, you'll remember that our procedure for this is to first make x equal to our initial expression. And I always write out 2 iterations of the repeating numbers just to help myself see it. Now our goal is to get 2 equations in which what is after the decimal is exactly the same. And that is so they'll cancel out. Exactly the same. So if I have x is equal to 0.16, I times this by 10, I'd have 1.6767. Sorry, no. 1.67167. Now, if I look at this, I start with a 0. I mean, after my 0, I start with a 1. After my decimal, I start with a 6. So I know that this is not the correct answer. So this is not the equation I'm looking for. If I multiply this initial expression over here by 100, I'm going to get 100x is equal to 16,7167167 ... Once again, here I start with 167 after the decimal. Here I start with 716. So it's not the right one, because what is after the decimal is not exactly the same. If I multiply my initial expression by 1,000, I'm going to get 167,167,167. And now I have what I need, because this matches this. So I can make this equation 1. I can make this equation 2. I subtract 1 from 2. Okay, and I'm going to get 1,000 minus 1. Remember, there's always a coefficient of 1 if there's no other value. 1,000 minus 1 is 999x. 167 minus 0 is just going to equal 167. And all of this is going to cancel out nicely. So to get x on its own, I divide both sides by the coefficient of x, which means I'm going to have 167 divided by 999. I'm not too worried about simplification here, but you can do it if you'd like to. It's always a good idea to simplify, but or maybe I should rephrase that. It's always a good idea to simplify, but I didn't mark you incorrect if you didn't simplify for this worksheet, just because we're starting off and I'm trying to give you guys lots of opportunities to learn. All right, now number B. Sorry, I'm trying to move this, but it's not working. I'm going to erase this, so I hope you've taken note. Okay, and I'm going to just put a line down here. Okay, B. My initial expression is 0,356, but the line is only over the 5,6, which means this is 0,3565656. This is my initial expression. Okay. You need to make sure you're copying correctly and that you're repeating the right numbers. Now, if I times this by 10, we always work in intervals of 10. So we take the initial expression, we times by 10. Then we take that expression, we times by 10. We take that expression, we times by 10. That's how we work with these sorts of things. If we times by 10, the decimal place is going to move 1. So that's going to be 3,5656. I can't use these as my 2 equations because this is different to what's after the decimal in this case. So I'm going to multiply this by 10 again. So if I take 10 times by 10, it's going to be 100. My decimal is going to move 1. I'm going to have 35,6565. This is not the same as this or the same as this, so I need to keep going. So you keep going in intervals of 10 until you get to that work. So if I take 100x times by 10, my decimal is going to move 1 point. I'm going to get 356,5656. Okay, now this is the same as this. So I can make this equation 1, this equation 2. Now I subtract 1 from 2. And I'm going to get 1000 minus 10 is going to be 990x is equal to 356 minus 3 is going to be 353. And everything that's after the decimal is going to cancel out. To isolate x, I divide both sides by 990. So it's going to be 353 divided by 990. The mark allocation here was 1 mark for getting your 2 equations. So for figuring out what your equations need to be, 1 mark for the subtraction and 1 mark for isolating x. Similarly, 1 mark for getting these equations, 1 mark for the subtraction and 1 mark for your answer.